Hello, today we're going to talk a little bit about trig derivatives. After we get done with that, we're going to move on to the quotient rule. So these three derivatives here, the derivative of sine, cosine, and tangent, these are your basic trig functions, and these derivatives you pretty much have to memorize. You're not going to want to derive those each time you have to use them. So using these three laws, let's try and take some derivatives of some more complicated trig expressions. We'll start with this one. Let's take the derivative of sine squared of x. So, we know that this is the same these two functions are equivalent. So now we have to use the chain rule. So what we do is we take the power of the inner function and bring it down. But now, because we're using the chain rule, we also have to multiply by the derivative of this inner function. So, the derivative of sine of x is cosine of x. So this expression here is our final answer. Let's try another one. Let's take the derivative of sine x times cosine of x. So in this instance, we have to use the product rule. You know that the product rule for two functions gives us that f prime of x times g of x plus g prime of x times f of x. That will give us the derivative of f of x times g of x. So, knowing that, let's take the derivative of this function. So f prime of x would be, let's say f is sine of x. So our derivative of that is cosine of x. Times g of x, which is also cosine of x. Now we add g prime of x and f of x. Well, g prime of x is going to be a negative sine x, and f of x is simply sine of x. So now we can rewrite this so that So that is our answer. The derivative of sine of x times cosine of x is simply cosine of x squared, or cosine squared of x, minus sine squared of x. Let's do one more example. So, let's take the derivative of sine of 2x. This will be another chain rule example. Remember, in the chain rule, we take the derivative of our main function and we just leave it alone for the time being. So the derivative of sine of 2x is simply cosine of 2x. But again, it's the chain rule, so now we have to multiply by the derivative of our inner function, which is just 2. So our final answer is simply 2 cosine of 2x. So that's pretty straightforward. That's pretty simple stuff. Just remember to use your chain rules, remember to use your product rules as normal, And now we will move on to another derivative rule called the quotient rule. Now, before we begin, you don't really ever have to use the quotient rule. Sometimes it's very convenient, but we can always just use the product rule and the power rule in combination and get the same result. Nevertheless, let's look at what the quotient rule is and how we derive it. So let's look at a general quotient. Let's say we want to take the derivative of some function f of x by some function g of x. So, first we're going to combine the product rule and the power rule and derive what we call the quotient rule. So we know that we can rewrite this as the derivative of f of x times g of x to the negative first power. Now we can use the product rule on it as normal, so let's do that. So all this becomes f prime of x times g of x to the negative first power. And by the product rule, we add f of x times a negative 1 g of x to the negative 2, and we have to remember to take the derivative of our interior function here, this g of x, so that we get g prime of x. Okay, fantastic. So this looks kind of ugly right now. Let's clean it up a little bit and see if we can get something to work with. So we have f prime of x over g of x minus f of x times g prime of x over g of x squared. Okay, so we're getting closer to a workable result. If we multiply this first fraction by g of x over g of x, all we're doing is multiplying that first ratio by 1, so we can certainly do that. That will give us the traditional form of the quotient rule, which is g of x times f prime of x minus f of x times g prime of x all over g of x squared. So now you've just derived the quotient rule. Alright, so now that we have the quotient rule, let's put it to use. Let's get something out of it and look at taking some real derivatives. We will start with the derivative of x squared plus 2x plus 2 over 4x plus 1. Alright, so if we begin with the quotient rule, we take the bottom times the derivative of the top minus the top times the derivative of the bottom, this is 4, and then all of this over the bottom squared. And that's our final answer. We can simplify it if we want, but this answer is correct, so we'll just leave it alone and move on to our next example. So now, let's let's take the derivative of tangent of x. Let's figure out how we get secant squared of x from the derivative of tangent of x. We presented it at the beginning of the lecture, but let's look at why it's so. So if we take the derivative of tangent of x, recall that tangent of x can be written as sine over cosine. Alright, so now we can use the quotient rule, and hopefully we end up with secant squared of x. So remember, it's the bottom times the derivative of the top, which is negative cosine, positive cosine, minus the top times the derivative of the bottom. That would be a negative sign. All of that over cosine squared of x. So right now this doesn't look like secant squared, but let's simplify it a little bit. So we have cosine squared of x plus sine squared of x over cosine squared of x. So if you recall, this up here, cosine squared of x plus sine squared of x is a trig identity, and it always equals 1. So this becomes 1 over cosine squared of x, which is secant squared. So we do find that the derivative of tangent of x does in fact equal secant squared of x. Alright, let's do one more trig example where we will use what we just found along with the chain. Actually, I apologize. First, we're going to take the derivative of secant of x, and then we have one more example. So, we take the derivative of secant of x. Recall that this is just the derivative of 1 over cosine. So, we take the bottom times the derivative of the top. Now, the top is just 1, the numerator. The derivative of 1 is just 0. And we subtract the top times the derivative of the bottom, which is just 1 for the top, and the derivative of the bottom is negative sine of x. All of that over the bottom square. So this first term here we multiply by 0, so that goes away. And all we're left with is sine x over cosine squared of x. Now, we can rewrite this as follows. This is the same as sine of x over cosine of x times 1 over cosine of x, or tangent of x times secant of x. So this is the typical form for the derivative of secant. Now that we know the derivative of secant, let's do another example where we combine it with the chain rule. So let's take the derivative of secant of x squared. Now, remember, with the chain rule, we take the derivative of this overall function and leave it alone. So all that is secant of x squared times tangent of x squared. Now we have to take the derivative of this interior function and multiply. So the derivative of x squared is simply 2x, and our final answer, I'll just rewrite it, is 2x secant of x squared times tangent of x squared. And that will be our final answer. That's all you need to know about trig derivatives in the quotient rule.